Good morning, everybody.
Good morning.
My name is Chris Noonan. I am a full-time instructor and department chair for Building Technologies, which is over air conditioning, heating and air conditioning, construction management, and industrial maintenance. Today's presentation is titled, "Did you say my flux capacitor is bad?" Okay? We've all heard that term before. So today, what we're going to do is we're going to learn about two different types of capacitors, two different methods of testing capacitors. Your tools needed would be a capacitor chart, which I have handed out to everybody, as well as a digital multimeter. Has anybody had any experience with capacitors? Does anybody find one that's ever failed?
Seen one with the top jammed up like a mushroom.
Mushroom or exploded. The one that really got me when I was out in the field, first starting out, was the capacitor looked good. It was not exploded, okay? It wasn't bulged out, and I took the wires off and I tested it, and it tested fine with my meter. I put it back into the circuit, and it wouldn't run. I sat there for about 45 minutes going, what is wrong with this capacitor and why doesn't it work? It looks like it's fine. Okay? And that's one of the things we're going to discuss today, is that it can, what I call bench test, or be out of the circuit, okay, and test fine, but when it's in the circuit and under a load, it's not fine. Okay? So the methods I'm going to show you today are two: a bench test and under a load test. And it works really great when you're doing a preventive maintenance, and you don't have to turn the system off. You can just test the capacitor right there. So that's what I'm going to show you today. Some safety items first. Okay, you can be dealing with voltage up to 440 volts. Right? So be careful. Capacitors end up storing the energy. Okay, so anytime the system is turned on, well, the electricity charges up that capacitor. So you've got to turn the system off, and you have to discharge that capacitor, because it'll hold it. Even though the system is off, it'll hold it. And if you get across it, you will get a nice shock to you. Okay? Very dangerous there. Okay? And as we go along and we do the exercises at the end of here, if you're not sure, ask. Okay? If you're not sure what you're doing, you're not 100% sure, I don't want you or somebody else to get hurt doing this. All right, everybody's good with that?
Okay.
All right, so the first thing we've got is we've got two types of capacitors. We've got start capacitors and we've got run capacitors. Okay, the easiest way to tell the difference between a run capacitor and a start capacitor is that the start capacitors will have a plastic casing. Also printed on it, it will be a range, a microfarad range on it. And I'm going to look at one here in just a second. The run capacitors will be in a metal casing, and that will have a definite microfarad reading, not a range. Not like 127 through 250 like a start capacitor would, but more like a 35 or a 5 or a 45. And it will have a definite microfarad rating on there. Okay? So again, tech tips. That start capacitor is going to be a range. The run capacitor is going to be definite. Okay? So before we get into this, let's look at the difference between a start capacitor and a run capacitor. So here's my run capacitor. It's going to be in a metal case. Okay? And you'll see here that I've got a 35 and a 5. So this particular capacitor can do two different microfarads. A 35 microfarad and a 5. Notice we said that's a run capacitor, so that's a definite microfarad reading. Everybody understand that? Okay, the one over here that says kickstart, right, that's actually in a plastic case. And I know it's a start capacitor because I'm in a range, 189 to 227. Okay? So next thing we're going to do is we're going to go ahead and test these right here. So first things, okay, I'm going to take a meter, set it right here, and I've got it set to microfarads. My range in microfarads here, and I'm going to take my two test leads, I'm going to put them across the two terminals, right here and right here. And it's kind of hard to read, but I've got 222 on it. See if I can kick that around a little bit. 222.8. That is within range of 189 or 227. Everybody's good with that? So now I've got a 35 side and a 5 side on the run capacitor. Again, metal casing. So I want to find my common. Between my common and my hermetic would be the 35 side, 33.9. Common and fan, 4.6. Also notice on here, it says plus or minus 5%. So as long as we're in 5%, that capacitor checks out good. And that would be how we would bench test the capacitor. Okay? Bench test, what I mean is like pulling it out of the system, no electricity to it, it's not running. Okay? So where would these types of capacitors be found? On permanent split capacitor motors. In an air conditioning, that could be the condensing unit or the outdoor fan, the compressor. What's in there? On the indoor unit would be your indoor blower motor in the air handler. So we just did that, went through the bench testing. Let's go through this one more time here. So we turn the power off to the unit. We discharge the capacitor with the resistor. We locate the microfarad rating on the capacitor, which we did. Using the multimeter, we set the scale in microfarads and put the test leads on each capacitor, and then we went ahead and read the reading, the actual reading, and compared it to what the capacitor said in print. Just like we did. All right, so testing it under a load, which is what we're going to do next. And this is the part that you can actually use for troubleshooting and preventive maintenance. Okay, so we don't have to shut the unit off. We can just test it when it's running. All right, so with the unit running, we want to measure the voltage across the terminals. Using one of the wires of the capacitor, we want to check the amperage, and we want to notate both the voltage and the amperage. And we can use the formula amps times 2650, which is a constant, divided by the voltage. The readings that you have obtained will give you the microfarad rating of that capacitor under a load. Okay. Use a microfarad chart to double check your work. So we have the microfarad chart. Everybody's received a copy of this. So if your voltage is on the side here and your amperage is across the top, okay, we can just cross-reference them with voltage and amperage to see what our capacitor is under or is doing under a load. Okay. So for instance, if you had 390 volts and 7 amps, what would your microfarad reading be for that capacitor under a load? What would go 390?
48.
48, right? Does everybody see that? Okay. If you run into a situation where the voltage is not in the chart here or in the range, use the formula. Okay? So again, you'll have to take your amperage and your voltage and or divide those out and then multiply by 2654, which is your constant for capacitors.
Is that going to have that 5% range?
No, it's not going to have it for the 5% range because this is under a load, and then you've got a good question. You've got to look at it and say, hey, if I'm rated at 45, am I plus or minus 5% with that number under a load? Because it very well could run at 25 microfarads when it's a 45 microfarad capacitor. If it's rated at 45, it could run at 25. But that's how you know that that capacitor is being devalued. Hey, Mr. Customer, you need to go ahead and change this. Let me show you what I found. Great question. So now, what we're going to do is I'm going to go ahead and move over on the machine over here, and we're going to go ahead and test the capacitor under the load. Okay? So I'm going to grab my meter. I'm going to turn this to voltage. Turn my system on here. Okay. So this is the capacitor that I'm testing here. And I want to go ahead and now check the voltage for it. So if I put my leads across the terminal, I'm reading 365. So let's write that number down, 365 as my voltage. I'm now going to set my meter to amperage, and I'm reading 6 amps. Okay. So using your chart under a load, what's the microfarad rating of this particular capacitor? 44. Does everybody get 44? Well, it's actually rated at 45. So under a load, this capacitor is good. Okay. All right. So let's recap what we've got here. Okay.
The 43 would have been bad.
43 probably would have been bad. Yes, sir. Yes, sir. Okay. So let's recap what we've got. Okay. Make sure you use safety when you're dealing with capacitors. It will charge up and it will discharge on you, and it will severely hurt you, severely shock you. Okay. We also learned how to bench test a capacitor, taking it out of the system and see what it's valued at. We also learned how to test a capacitor under a load, so we don't have to turn the system off. We can actually see what that capacitor is doing. Okay. Again, use safety and caution when doing this. And now the next thing that we're going to do, okay, is our hands-on exercise. We're going to go ahead and change units and perform both bench test and the load test of the capacitor. So we're going to go on different units here and do both bench testing and testing under load. And just to remember, start compators are only in the circuit momentarily and only can be bench tested. Okay? The plastic ones can only be bench tested. All right, guys, I want to thank you. We're going to go ahead and cut this short now, and we're going to go ahead and move into the hands-on exercise.